So we are going to go over the correct answers for your 3A quiz. The first one says, classify each number as either rational or irrational, and it has a bunch of square roots. Remember, rational numbers can be written as a fraction, while irrational numbers are decimals that never stop and never repeat. So some easy ones that we can pick out here would be perfect squares, because perfect squares are going to simplify to whole numbers which are rational. So for rational numbers, we have, insert an equation, the square root of 4, because that is 2, and you can put on your answer key that it equals 2. Okay, but as long as that square root of 4 is there. Another one would be the square root of 16, which is 4. And then we have the square root of 64, which is 8. And I believe that the square root of 256 is also a perfect square. I believe it's 16. Okay, and then everything else is going to be irrational. Oops. So remember, rational numbers can be written as whole numbers, fractions, those types of things, while irrational numbers cannot. Number 2, how many irrational numbers are between 1 and 6? Change my color here. So the correct answer is infinitely many. Okay. And we talked about this, or we read about this in The Number Devil. And it talked about how you could have 1.1 or 1.123456789, and all of those numbers are between 1 and 6. So you can add an infinite number of places behind the decimal point and still be, in this case, between 1 and 2. So for every whole number, you could add that decimal point and still be between 1 and 6. Okay, simplified for this. Let me switch over here. I'm going to come up with the factors of the square root of 45. So factors of 45 would be 1 and 45, 3 and 15, and let's see, not 4, 5 and 9, and that should be it. So my perfect squares, my biggest perfect square here is 9. So I'm going to rewrite this. I'm going to blue again. And we're going to insert a new equation as the square root of 9 times 5, which equals, split these up, the square root of 9 times the square root of 5. The square root of 9 is 3, so we are left with 3 times the square root of 5. I'll go ahead and copy this and put it down here. for my final answer. Okay, to approximate the value, I'm going to think of a perfect square that is below 45. So a perfect square below the square root of 45, or below 45, is going to be, what, 36? So 36. And that just so happens to be the same thing as 6. Okay, so then we get the square root of 45. And a square root higher than 45 is going to be the square root of 49, which is 7. Okay, so then I know this is going to be 6 and a fraction. I'll go ahead and enter my fraction in here. Fraction. My numerator is the distance between 36 and 45. So that is, what, 9. And my denominator is the difference between 36 and 49. So that is 30 or 13. So my answer is 6 and 9/13. Put that down here. Uh-oh. There we go. And that is how you simplify and approximate. All right, number 5 wants us to place these numbers on a number line. Okay, so when I look at these, the first thing that I believe is kind of easy to see is the square root of 4. And the square root of 4 is 2. So that's going to be over here. We're going to insert, and we're going to write it the way that it is given to us. So this tick mark is 2, because there are 1, 2, 3, or, well, yeah, 3 spaces to get from 0 to 1. So there need to be 3 spaces to get from 0, or from 1 to 2. Okay, and then 2/3, that's pretty simple because there, again, we're 3 spaces, so we have 1/3 would be here, and 2/3 would be here. So this would be this one. Go ahead and change over so you can see what I'm writing. And 2/3 is a fraction in the problem that's given, so we're going to go ahead and do that. And we'll scoot this one back over. So every time I add one, I'm going to have to work on the spacing on this one. And then this 0.33 repeating is actually 1/3 as a decimal, so you would be expected to convert this over. You can convert it over by knowing that your 3 will be the numerator and a 9, and then you can divide that by the common factor of 3 and get 1/3. Okay, so then you would know that it needs to be placed right here. 0.33 repeating. We may have to make this smaller so it will fit. But you want to write it in the form that it is given to you. Okay. So now we need to work with the square root of 2 and getting that in the correct place. And the best way to do this is going to be to approximate its value. So the square root of 2 is bigger than the square root of 1. yet it is smaller here we go, than the square root of 4. Okay. And the square root of 1 is 1, while the square root of 4 is 2. So this is going to be 1, approximately, 1 and a fraction. So it's 1 away from 1 and 1/3. Okay, this is approximately 1 and 1/3. So we can actually place that about right here. And I was very lenient when grading as to if you put this in the correct spot or not. If it kind of looks like it's in the correct area, then I tried to help you out. Okay. So main thing is you have 0.3 repeating, 2/3, then you have the square root of 2 and the square root of 4. Okay. All right. Number 6. On number 6, it is asking you basically to solve the equation. So we start with 2x plus 3 equals 3x minus 4. Then we are going to move our constant to one side. So we're going to subtract 2x from both sides of the equation. And that leaves us with 3 equals 3x minus 2x is x minus 4. And I'm going to go ahead and move this over so it kind of lines up nicely. And then we are going to move the constant over. So this means we're going to add 4 to both sides, plus 4. Again, I'm going to move this over. And we are left with 7 equals x. So your work should look something like that. And then down here, when you write your answer, you could put x. Actually, no. Once you know that 7 equals x, you need to go ahead and plug that in. 2 times 7 plus 3 equals 3 times 7 minus 4. You want to check your work. So 2 times 7 is 14 plus 3 equals 21 minus 4. Let's scoot this over. And then we add those together. 14 plus 3 is 17, and 21 minus 4 is 17. So if this equals out, then you know it is true. So you can put your answer down here, that x equals 7. Okay, so this is what you start off with, a line that looks very similar to this. And it says to complete the square. So to get all the points on this, you must complete drawing the square. So this is the first step to getting a 4 on this question. And then it says to find the area. So to do that, I told you in class that I really liked looking at the rectangles of these. So I would look at the rectangle that is here. Let me change this color. That. And I would say, well, that's 1, 2, 3, 4, 5, 6 square units that I have now cut in half with that diagonal. So that section right there counts as 3 square units. Okay. And that is going to happen on all of these rectangles. And then right in here on the inside of this is going to be 25. Okay, so what we have is our corners are 3 square units all the way around, and then our center is 25 square units. So what we end up getting for our area is 25 plus 12, which is 37 square units. So we end up getting 37 square units by taking 3 plus 3 plus 3 plus 3, which is 12, and adding it to 25. And then our side length is going to be the square root of 37 units. And the program I'm on right now doesn't have a square root symbol, so you would put a square root symbol on yours. And that is number 7. Okay, number 8 says, what is the greatest common factor of 42, 126, and 210? So, we need to find out what the factors of each are. Factors of 42 are 1 and 42. Then we have 2 and 21. And I would assume 3 and 14. 5 is not 1. Or 4 is not 1. 5 is not 1. 6 and 7. So that's going to be it. This kind of gives us a good place to look for 126. We know 1 and 126 would be a factor pair. And I'm just going to go with the ones that are given in 42. So we know that 2 and 63 work. We know that 3 and 42 work. And 42 and 42 here, so that's kind of a key. Maybe we're onto something. I don't have to try 4 or 5, so let's try 6. That's going to be 6 and 21. Let's try 7. It's going to be 7 and 18. And let's try 14. That's going to be 9 and 14. So right now, if it was just 2 numbers, it would be 42 because that's the highest that we've got. Let's throw 210 in there. We know 1 and 210 is going to work. We know that 2 and 105 will work. Let's try 3. We know 3 and 70 will work. You know, why don't we go ahead and try 42, since we already know that's the greatest common factor of the rest of them. Okay, and that is 5 and 42. So 42 is a factor of all 3. That means that the greatest common factor of those numbers is 42. Okay, number 9 is a great word problem we have. So it says, sales for a business were $3 million more the second year than the first. The sales for the third year were double the sales for the second year. If sales for the third year were $38 million, what were sales in millions of dollars for the first year? So I'm going to use our equation skills to figure this out. And I'm going to say X equals sales for first year. And the sales for the second year are going to be represented, it says, as $3 million more the second year than the first. So X plus 3. And sales for the third year are going to be represented as double the sales for the second year. So we'll say 2 times X plus 3. Or, which is the same thing as 2X plus 6. And then they say that for the sales were $38 million the third year. So I can say 2X plus 6 equals 38. Because I'm not writing millions, I'm just looking at the whole number part of this. And then I can subtract 6 from both sides and get 2X equals 32. And then if I divide by 2, then I get X equals 16. And the question is, what were sales in millions of dollars for the first year? So it's going to be $16 million. And we can go back and check this to see if it works out. So we have 2 times 16 plus 6. 2 times 16 is 32 plus 6. And 32 plus 6 is 38. So it did check out